Assalamu alaikum dear students. Bismillahirrahmanirrahim. Welcome back in lecture 31. Glad this is lecture 31. In this lecture basically I choose a 2D frame from chapter number 11 of R.C. Hebler book. Clear? You can see the frame structure, this is a 2D frame, and you see that your A, C are pen support and B and D are flex support, and EI is constant. Clear? It is subjected to 8 kF loading. Clear? So let's see how we model it and how we analyze it. Clear? Make sure your units will be kept feet. Clear? New model, and let's say we will use this one. Now you need to understand, there are two bays, one in this one and one is this one. So you have two bay, and you have only one story. Clear? You have only one story, and story height is 12 feet, and the bay width, this bay width is equals to 15 feet, but this bay width is equals to 20 feet. So we need to edit grid spacing. Clear? So let's see how we can do it. We have number of story equals to 1. Studio height is fixed, that is 12 feet. Okay. We have two number of bays, and let's say we edit the bay widths. Clear? Spacing kF feet from A to B. Okay, your bay width is 15 feet. From B to C, your bay width is 20 feet, and your Z1 to Z2 height is okay. So this is the way that how we will use a frame template. Clear? So now we have to use this template. Clear? We don't need this member, we don't need this member, so delete it. Clear? We have, I think so, flex support here, and this one is also flex support. I think so, this is pen support. A, D, C. Let's see. Assume A and C are pen. Oh yes. This support is flex support. Okay. This is flex support. This one and this one are hinges. Clear? So these are the supports. Clear? We need to rotate. Okay, it doesn't matter, I think so. If you rotate or not rotating, I think so this doesn't matter, because it don't contains any incline loading. Or let's say we rotate it. It is not a difficult task. Joint local axis and rotate this from about y axis with a negative sign, minus 90 degree. Clear? Okay. And this one, sign joint, sorry, with a positive sign. Clear? So now we will assign the loading. The loading is applied to the midpoint. Assign frame load, point load. Make sure this is 0. Modify, OK. Kif feet, global axis, gravity, OK. Absolute distances. At a distance 10 feet, you have a load that is at kif. OK, this is load. Now we will assign loadings, joints, members. Let's see we analyze. Save it. This is example number 39. Okay. We need joint reactions. So these are reactions. Okay. We have also shear force and bending moment diagram. So let's see shear force and bending moment diagram. Maximum 28, and this one will be minus 8.79 and minus 22.96. So let us check it. 28 minus 8.78 minus 23 are roundabout. Okay, minus. So we done. Okay, the results are, the results are okay, satisfied. This is minus 7 point something, so this is roundabout 7. Okay, so if you are interested in shear force, you can show the shear force diagram as well. Okay, so this is the way that how we can analyze a different type of frames. Clear? So this example we done. Okay, so you can assign this. This is fixed and C is hinged. Clear? And this is one bay, one story. Bay width 15 feet and story height is 12 feet. So you can do this by yourself. Okay, it is simple. The shear force and bending moment diagram of this you can do and check with this. Okay, this one I did this example. Okay, but I have only one point load, so the load is applied here. Okay, that is UDL. So you can model it and apply loading to this member in positive x direction. Okay, so it has two bays, one story, and it is in kilonewton meter units. The first bay is a 6 meter, the second bay is a 6 meter, and the story height is 8 meters. So this is simple. Okay, it's not tricky. This is at shear and moment diagram. You can check it. Clear? Let's see, we will do this example. Clear? Now before modeling this, okay, I want to explain this diagram a little bit. Clear? If I use a frame template, we have how much bays? Okay, we have, okay, this one, this one, this one, and this one. So 1, 2, and 3. We have 3 bays in this frame, and we have only one story, and the story height is 12 feet. Okay, the bay one width is 5, the 2 is 10, and 3 is 5 feet. Clear? So, and you see that A and B are pin supports, clear, and EI is constant, clear. D and C are fixed support, clear. So let's see, units are in KEF, okay, so units are okay, yes. We use 2D frame template. We have one story and the story height is 12 feet. We have 3 bays and we use to edit the bay widths. Select spacing. The first bay width is 5 feet. The second bay width is, I think so, 10 feet. And the third bay width is 5 feet. Okay, this is okay. Okay, this one, delete this one, and now we will develop our required frame within this 2D frame, clear. So you can see that select this frame element, okay, click this one, clear, and then select and click this one and this one. So now delete the rest of the elements. We don't need this one, we don't need this one, and we don't need this one, so delete it. This is the required frame, okay. Though this is point A and this is, I think so, point B. Both are hinges. Assign load, frame load, distributed load. Make sure this is 0, okay, because self weight multiplier, we don't need self weight, KEF feet, global, gravity, and we have a dead load of 3 kip per feet. Okay, this is the loading. Now we go to analysis, save it. This is example number 40, okay, 40. This is example number 40. Save it and see the results. So we check it. This is a shear force diagram. The maximum shear is 15 and the maximum movement is 24. Okay, these are reactions, okay, and this will be the shear force diagram, okay. Maximum shear is 15 and 15, so we have 15 and 15, and let's see the maximum movement. The maximum movement is 22, say 23 or 23, clear. There is 24, so roundabout, we are close. So we're done that example. You must know that this is why this difference is. This is roundabout 24 because sap2000 assume this as a straight line, although this is not a straight line, clear. This is basically a second degree parabola. This is a second degree parabola, and sap basically assume it as linear, okay, that divide this curve in linear segments, clear. So due to that, they give you the value of this one, that is roundabout 23, clear. If it takes this curve value, then it will be 24, okay. So that is the why we are close, okay. I say that we are close because due to this kind of error, okay. This is the basic reasons behind, that our results are basically a little bit lower, or you can say than the exact one. Clear? So we done this example. Now we basically does this example. Clear? So here you will learn a little bit more about about your grid spacing. And okay, we can see that we have only one bay here. Okay, we can see we have only one bay. Clear? We have only one bay, and this is the bay, and bay width is basically 3 meter. But here you can see that this is Z1, this is Z2, and this is Z3. So we have two story, that is the first story 4 meter and the second story is also 4 meter. So I think so there is symmetry, and if there is symmetry, so you can use a 2D frame template, that is a little bit easy. Clear? So let's see, and I think so the units are kilonewton meter. Clear? The units are kilonewton meter. Okay, kilonewton meter. Select 2D frame template. We have two story. Story height is basically 4 meter. Okay, we have one number of bay, and the bay width is basically 3 meter. Clear? The bay width is 3 meter. Story height, each story height is 4 meter. Clear? And then okay. So this is the frame. Clear? We don't need this one, so remove it. And basically these E and C are fixed. A, C and E are pins. Sorry, this A, C and E are pins. So we will assign this one as pin supports. This is pin support. Clear? And we need to rotate it. Okay, assign joint local axis at a degree of minus 90 degree. Clear? Now we will assign the loading. We have to assign 12 kilonewton per meter, and lower story, that is this is you people must know that this 2D basically it is a front of a veranda, you can say. For example, if these are the rooms, or you can say this is the front of a plaza. Okay, so there you can see that there are columns. Clear? There are columns. Okay, so if it is, this plaza is basically 2 story, so 2 story, so at each floor we have beam at each floor. So if you cut across section of this building, so you can see a picture like this. Okay, this is the room area. Clear? And this is the column in front of the room. Okay, or you can say the veranda column, and there is first floor beam. Okay, and there is second floor beam. Clear? And the loads are calculated, and that are shown there, that are shown there. Clear? And this is the kind of modeling. They model that practical problem into 2D. So this is, this is a kind of modeling. If you have asked to draw a model of a veranda, or you can say any room, etc., any plaza, etc., so you can use these techniques, that how these models, how these 2D models are prepared. Okay, so you must know that what is basically so many students I will see that they don't understand what does it mean. Okay, what does it mean that this is, they just consider it as a shape. Okay, this is not basically a shape. It is, this problem is basically selected from a real world problem. Okay, and they are modeled into 2D shape, the loads are calculated, and the results are okay in front of you. This is a steel structure model. Clear? So whenever you are dealing with these frame structures, you must compare this with the real world problems. Okay, that where this kind of situation is possible. This is column, this is, this is beam, so this is wall support. Okay, so basically you people must understand this kind of problems. Clear? In real world scenario. So let's see, we will assign the loading, that is 12 kilonewton per meter. Make sure this is 0. The loading is 12 kilonewton per meter. Direction is gravity. Okay, you can use this one or this one. Okay, this is the first loading. The second loading is 16. Okay, at first joint we have 10 kilonewton, so assign. Now you have to select joint loading. Okay, if you select a joint, then you have to use joint loadings. Okay, the load is applied in a positive x direction. Clear? In a positive x direction, this one, 10 kilonewton. Okay, then this joint, sign, joint loads, forces, and there is, you have 15 kilonewton. Okay, so if you are confirming the loading, display, forces, these are your loadings. So now we do the analysis. Save it, that is 41, example number 41. Save it, and this is the shear force and bending moment diagram. Sorry. So let's see, we compare the result. This is the shear force diagram and this is the bending moment diagram. You have maximum bending moment here 9.74 and there is 12.3. Okay, so column is subjected to lower moment and beams are subjected to higher loads. Clear? And you see there the maximum shear in beams. Okay, maximum shear in lower beams, that is 28.1, and in column there is less amount of shear. So let's see, we will check. Okay, 12.31, the bending moment diagram is okay. Let's see, check it. The shear force diagram, shear about 2. Okay, so we can see 27.75 kilonewton, that is our maximum moment. 28, 27 roundabout, we are close. Clear? So this is the way that how we will analyze a two-story structure. This example is also easy. I did this example, okay. And this is basically chapter number 11, okay. You can do this example as well. Assume A and B are fixed. So A and B both are fixed support. You have only one bay. The bay width is 3 meter, and the story, you have only one story and story height is 3 meter. You select this, okay, and at 0 you have 30 kilonewton, and at a distance 3 meter you have 0. Select assign menu, frame loading, distributing loading, and in distributing you will use the absolute spacing. So you select this. If you are confused that from what side the 0 is started, so you can make 2 attempts, and one attempt you assume that 0 is started from there. You have 2 columns, okay. You have distance. In distributed load, when you are using absolute distances, you have 2 columns, okay. You have load, okay. So there you can say, let's say at 0 I have 3 kilonewton, and at a distance of 3 meter I have 0 loading. And click OK and see whether the load is model in this shape or not. Okay, if the load is model in this shape, clear, so then you will understand that the 0 is started from the top, okay. Then you can say that at a distance of 3 meter, or you can say at a distance of 0 I have 0 loading, and at a distance of 3 meter I have 3 kilonewton per meter loading. So then it will be, the loading will be model in this shape. Clear? So if you are confused that from which side the 0 is started, clear? So this example is easy, These are the results. You can compare. This is the second degree curve for shear force, and this is the third degree curve for bending moment diagram. Compare your results with this diagram, okay. This example I did, there is only a 6 skiff thrust, okay, that is acting at point B. So you model it and select the joint B, and in X positive direction, the loading direction will be not gravity. You select positive X, and then insert a value with a positive sign, okay, 6 skip. Okay, you select joint loading, but you cannot do this example because E and I is, that is given. So inshallah I will did this example in my design portion, okay, because we have to define these properties, and then we can assign this, we draw these beams. Clear? Now we do this example, and this will be the last example of our chapter 11. Clear? So this is a sample example. We have 2 bay, 1 bay and 2 bay, and we have 1 story. The first bay is 6 meter, and the second bay is 4 meter, and the story height is 8 meter. So let us we do this, okay. Units are kilonewton meter. Clear? Select this one. We have 1 story, and the story height is 8 meter. Clear? We have 2 bays, and we edit the bay widths. Spacing kilonewton meter. Make sure these units. The first way I think so it is 6 meter, and the second one is 4 meter. Clear? We don't need this one, and this one is okay. Okay. So this is your model. Now we check the supports A, D and F. A, B, E, D and F are all pin connected. Okay. So, and we have a joint load. Clear? So, let's see. Select this joint and assign joint load. Okay. Forces. Make sure this is 0 and modify. Okay. And kilonewton meter. Okay. You have to apply load in x direction but with a negative sign. So that is minus 12. Okay. With a negative sign. And okay. So this is the way that how we model it. Model. Do not run. Run now. And this is example number 42. Save it and do the analysis. This is shear force diagram, and you can see your joint reactions. So this is the end of this chapter 11. Okay. I attempt all the frame questions from this chapter. Okay. If you have any question, any comments, please share with me. Watch the video and enjoy. Thank you.